Hello! In this video, we present the synthesis of retigabine, according to its retrosynthesis presented in the previous video. This synthesis is based on connecting the aromatic rings through the benzyl amino group, formed by the condensation between nitrophenylenediamine and para-fluorobenzaldehyde obtained from commercially available and accessible raw materials. Subsequent functional group transformations culminate in the synthesis of this drug, as we will see later. The regioselective nitration of acetanilide uses sodium nitrate in the presence of sulfuric acid to form para-nitroacetanilide 2, whose nitro group is reduced to the amino group, using metallic indium as a reducing agent, given its low oxidation potential in the presence of ammonium chloride, to thus obtain para-aminoacetanilide 3. A second nitration, now using a mixture of nitric acid and sulfuric acid, regioselectively generates nitroacetanilide 4, since the nitration position is determined by the combined effect of the protonated amino group in the acidic reaction conditions that directs to meta, and by the ortho orientation provided by the acetamido group. The acidic hydrolysis of the acetamido group yields nitrophenylenediamine 5. On the other hand, to prepare para-fluorobenzaldehyde, fluorobenzene 6 is regioselectively brominated using N-bromosuccinimide activated by the action of hydrated boron trifluoride to generate para-bromofluorobenzene 7. The reductive carbonylation of the aromatic ring of compound 7 is carried out using flow chemistry techniques with synthesis gas formed by carbon monoxide and hydrogen, palladium acetate as catalyst, and the phosphine ligand, shown here, to obtain para-fluorobenzaldehyde 10. It is worth noting that the application of flow chemistry in this case is ingenious and adequate for handling pressurized gases and reactions in a gas-liquid medium. The condensation of the amino group in 5 and the aldehyde in 10 in an acidic medium forms imine 11. The amino group in 5 that reacts corresponds to the one in the meta position relative to the nitro group, since the other amino group, being ortho to the nitro group, is less nucleophilic. The reduction of the imine is carried out with sodium borohydride to form benzylamine 12 with high yield. Next, the more nucleophilic amino group, which corresponds to the benzylamine, is protected by reaction with benzyl chloroformate to form intermediate 14. Next, carbamate 16 is prepared by reacting the amino group with ethyl chloroformate. In this reaction, the need to first protect the aminobenzyl group becomes evident, as it is more nucleophilic than the other amino group. Finally, all that remains is to reduce the nitro group to the amino group and deprotect the benzylic amine. Both transformations are achieved by palladium-catalyzed hydrogenation on carbon to synthesize the drug quantitatively. In summary, here are the intermediates and main raw materials and their structural contribution. Thank you for your attention.